Good morning. Welcome to the Design Make Play show. My name is Siri Jones from Zen Maker Lab, and I am going to be your host for today. Zachary, our usual co-host, our usual host, is away today. He's been working really hard, so he's just going to take the day today. And lots of exciting things to tell you about. We have our first contest winner that I'll announce in a few minutes, right after we have a bit of a video showing about the prize. But just before that, a quick overview of what we're going to cover today. So today we've got our some cool design, make, play segments as usual. We also are going to be showing our Zen Shield story in the second half of the show, the first half of the second half of our show. And then we're going to have an interview with our very own Fardine Bearcat, who's invented a very cool solar-powered RC boat. So stay tuned for all the cool things on the way in this morning's Design Make Play show. First, let's watch the Canucks prize donor video about the contest.
Let's go ahead and take a look at our very first project here, which is Clancy's boat. Set sail for Impress, and this one is Jackson's R2D2. Now this cannon was made by Oscar Hudson's Deluminator. Next up we've got Daniel's Dice. Check out Oscar's Lantern. Here, let's play some Keaton's Crossy Creek.
Hello, well, you heard about the contest. Well, guess what? We have our very first winner to announce this morning. So the panel got together last week and decided that the winner is, and let me just show you what the winner is going to win first. This is a very cool Vancouver Canucks hockey stick signed by Bo Horvat, and this is really awesome. So the winner of our first week of the Summer Giveaway Challenge is Jaden and Jaden's Dragon. Check out what Jaden's Dragon did. You saw a little bit of this last week when Zachary profiled some of the projects. So this was designed in Tinkercad. It's a 3D model, 3D design. It was something that was 3D printed. It is a very cool dragon. So congratulations to Jaden. We'll be following up with you shortly. And for all the rest of you, thanks for your submissions from last week. And don't forget to submit this week. What you do is you send an email to designmakeplay@zenmakerlab.com. And we're going to be reviewing submissions throughout the week, some which will be on the show in our Maker Highlights section. And we will pick again another lucky winner for the following Monday. Also, two honorable mentions. Enzo from the Mulgrave camp that did a really cool LED nightlight and a really nice design of his name, kind of like a logo type looking design. And also Maple from the same Mulgrave camp built a really cool LED nightlight and had a really cool design on it as well that kind of made it unique and special. So we'll have some small 3D printed prizes for those two runners up from the first week. Once again, a lot of really great submissions from everyone. Thanks for what your contributions. And we'll keep looking at them. There's still lots of prizes to be won. We're only in week 1 of week 8, so all kinds of cool prizes still to come. Stay tuned. We're now going to be moving into our design segment, so enjoy.
Hello and welcome to another segment of Design Make Play TV. My name is Aryan, I'm the designer at Zen Maker Lab, and this week Sarah and I will be exploring the concept of body and face proportion. Today I will be teaching you guys how to draw a face accurately. So have your pencil and paper ready and let's jump into it. As you guys remember from the last week's segments that I did, the 1 point, 2 point, and 3 point perspective, I used guidelines to have my drawing in a perfect proportion. We're gonna have the same idea for drawing the face. We need some guidelines to position the eyes, the nose, the chin, the forehead, the hair. All these positions should be in an accurate way. So for start, I'm just gonna start off with drawing a circle. So I'm gonna draw a circle. One tip for drawing stuff is you should always be fearless of drawing lines and be really friendly with your paper and pencil. So I drew my circle here. What I'm gonna do next, I'm gonna divide my circle to half. So one from top to bottom in the y-axis, and another one going from the x-axis. So length and height. I make sure this is really accurate and it's in the middle. Next thing I'm gonna do, I'm gonna divide the two parts in half too. So what we end up with is 1/4 of each part. So I'm gonna divide the top part to half and the bottom one to half. So we're gonna have a quarter, a quarter, a quarter, and a quarter. After I drew this, now I know that this is my top point. This first line on the top gonna be my hair. The middle one gonna be the forehead, this part, and then bottom one gonna be the eyes, and really at the bottom gonna be the nose. So the rest of the mouth and the chin I'm gonna draw another circle at the bottom of it and draw from the point of the eyes, I'm gonna draw another circle and have it there. So the mouth gonna go in the middle of here, and the chin gonna go all the way down. So this thing, the whole second circle gonna be half of the rest. After that, I'm gonna start off drawing the actual parts. I'm gonna grab one of my more sharp pencils and then draw the eyes first. I'm gonna draw the eyes first. Really basic eyes. And then, as we said, the bottom of the first circle gonna be the nose, so I'm gonna draw the nose. Eyebrows, the mouth, I'm gonna connect these together, and the chin. The ears gonna be lined up with the bottom of the eyes. It's gonna be the hair. Neck. So here's the drawing of the face. So this is how you draw a face proportionally. There we go. Now we have our face ready. So tomorrow, Sarah is going to be showing you how to draw the body in accurate proportions. So stay tuned and be ready to draw that. Hopefully you guys enjoyed this segment. My name is Aryan. I'm the designer at ZenMaker Lab. Take care and goodbye.
You know, I've been reflecting on that last episode when the hands broke on our clock. Can somebody lend me a hand? And I think that we should make an LED clock that doesn't rely on mechanical hands, but rather light. Why not light? But before we can do that, we have to investigate a couple important principles of light. In this episode today, we're going to be learning about refraction, reflection, the critical angle, and the power-angle relationship. I'm Zachary Anderson, and let's jump into this enlightening segment on light. So here's a great simulator of a laser. So in this simulation here, we can see that we're pointing a laser at a body of water, and there's 3 rays here. So the ray that's coming out of the laser, this is known as the incident ray, and it's coming from our source into some boundary. Now there's a ray that's coming off that boundary, all right, it's being reflected. This is our reflected ray. And then there's a ray that goes into the boundary, and that's our refracted ray. And as I move this around, you can see that the angles are changing. The 2 angles on the top and the 1 angle on the bottom, right? This is known as the incident angle, the reflected angle, and the refracted angle. And they're changing, and we want to understand how they're changing, because it looks like they're changing at different rates, at least these 2, in terms of our incident angle. So we're going to take a look at how to figure out the exact relation and see if it's really what it's all chalked up to be. So, like in that simulation that we just came from, we can see we've got those 3 rays. So our incident ray, the ray that's going into the material, is in red here. We have our reflected ray in orange, and we have our refracted ray in purple. And we want to understand how the angle of each ray is determined by the indexes of refraction and the angle of our incidence ray, okay? The ray that we initially point into, all right? So if we're pointing the ray, say that we're holding our laser pointer like this, and we're pointing it directly into the material, that would be indicated by this line here. This is known as the normal, okay? The normal line. And that is the line that is perpendicular to that boundary, okay? So we can see along here, this is the boundary between air and, in our example, acrylic, okay? And this is the normal line to that boundary, okay? And we measure the angle, the incidence angle, from that normal line to the ray. So this little curve here indicates my incidence angle, and we denote that with a theta I, okay? And then we've got the angle here, for our reflected ray, which is the theta R. And then we've got an angle here for our refracted ray, this theta 2, okay? All right, beautiful. So let's start first with the law of reflection, which says that theta I is equal to theta R. Okay, so the angle of the reflected ray will always equal the angle of the incidence ray with regards to this normal line, okay? So these 2 angles will always be the same. As I move my incident ray out like this, my reflected ray will move out like that as well, okay? So that seems pretty easy, that seems pretty simple. But now let's talk about refraction. Now, normally for refraction, we talk about Snell's law and this sinusoid, but rather than doing that, we're going to think about circles, okay, and ratios. So imagine here, I've got this beautiful circle. We're going to call this the unit circle. So the point from the center out to the circle, okay, the distance from the point from the center out to the edge here, it's going to be 1. And so all of these arms here for the incident ray, the reflected ray, and the refracted ray are all going to be 1, okay? Now, we're going to talk about where that arm points to on our circle in relation to the normal, okay? So here we've got our incident ray, it's coming in, and it touches the circle here, okay? And if we go exactly horizontal over to the normal, that's going to give us this distance. We're going to call that Li, okay, Li. And similarly down here for the refracted ray, we're going to take this point to that normal. We're going to call this length L2, okay, this length L2. And we've also got our indexes of refraction, and each of those is going to be somewhere around 1, at most maybe 4, that's really high, okay? And air is 1, and our acrylic is actually 1.5, okay? So n equals 1 and 1.5. And this length L2 is actually only going to be equal to n1, the index of refraction of air, divided by n2, the index of refraction of acrylic, multiplied by this length here, okay? All right. And this gives us some good idea of how things will change when we change the materials that we're using, right? If we use something with a really high N2, okay, now we know which way things are going to change. So for example, let's say that our index of refraction for the acrylic is like 100. So this is going to become really, really small, right? Anything, 1 divided by 100 is going to be a really small number, right? And so L2 is going to be some number that's really small multiplied by some other number, which is going to give us probably a pretty small number. And so this ray, now we know that this length is going to be really small. We know that it's probably going to be pointing straight down. So this gives us a sense that as we increase the index of refraction for the material we point into, our ray is going to pretty much permanently be bent down, okay, towards the normal. And similarly, if we decrease that and we increase this one, it's going to bend the ray the other way. It's going to bend it up, right? So this gives us a sense of how these work. So that covers our laws of reflection and laws of refraction. So now let's talk about the critical angle. So here you can see I've got my laser pointer and I'm shining it from a material that is a higher index of refraction into a material that's a lower index of refraction. And as I increase the incidence angle, all right, the angle at which I pointed into the material, there's going to be a point at which that refracted ray, the ray that we see inside that other material, disappears. That exact point at which it disappears is known as the critical angle. And now the laser is entirely reflected, okay? None of it is actually transmitting out of the material. It is purely remaining inside of this glass, okay? So that is the critical angle. In this example, this is our critical angle. So that covers the critical angle. Now let's talk about the power angle relationship. So you can see here that when I point the laser directly into the material, this reflected ray is very, very faded. And as I increase that incident angle, okay, it becomes much more opaque, right? Much more solid. The shade of that ray is an indicator of how bright that light is, how intense that light is. So as I increase the incident angle, okay, I'm increasing the intensity of that reflected ray. And as I decrease it, I am decreasing its intensity. And similarly for the refracted ray, the ray that goes into the material, as I decrease the incidence angle, I am increasing the intensity of that ray. And as I decrease the intensity of that angle, as I increase the incidence angle, I decrease the intensity of the refracted ray. So that covers everything about light that we wanted to talk about today. Thank you guys so much for checking out this video, and gals, I'll see you in the next one.
Good morning, everybody. My name is Rodney Gilbert. I played 4 years at the University of Mayville State, and I'm here to teach you guys the fundamentals of baseball this week, which would include throwing, catching, infielding, outfielding, and of course, hitting. After this week's session, you should be able to jump right on the field and play baseball. So let's get started. For our first drill, we'll be getting warmed up. Usually people just jump into throwing without getting their arm properly warmed up, and that leads to injury further down the road. So for the first set of warm-ups, we're gonna be doing jobs. So you're gonna start with your elbow out, glove in your hand if you have it. If not, doesn't matter, you don't need it. Hand on your elbow, and you're gonna be raising your palm to the sky, and that's the warm-up. So you do that for 10 reps. Okay, and then from there, you're gonna go elbow to your side, palm out. And you're gonna do that for 10 reps. Okay, next drill will be elbow up, palm down, and you're gonna raise your hand all the way up, and then go all the way back down. All the way up, and all the way back down. So we're gonna do that for 10 reps. After you finish those, we're gonna finish off our stretching with elbow raises, which is elbow at your side, and then elbow right to the sky and back down. Elbow right to the sky and back down. You want to do 10 reps of that. And if you feel like it, you can do these on both arms. Usually I just do it on my throwing arm to get the blood flowing before I start throwing an actual baseball. Okay, for our first throwing drill, we're gonna grab a ball, we're gonna drop to our knee, we're gonna get into the dart position, which would be palm up, hand on your wrist, and you're just gonna make 10 throws to your partner or off the wall, just like this, only using your wrist, just like you're throwing a dart. Yep, so after 10 reps, you're gonna switch to no arm on your wrist, a little bit more of an arm motion. So bring your arm back a little bit, and you're gonna be throwing from here. Just like that, for 10 reps. After those 10 reps, you're gonna get into a proper throwing position. You're gonna rotate your body to the side. You're gonna raise your arms like this. You're gonna drive this elbow down and come through with your right arm. There's gonna be 10 reps of throwing like this. After you get your 10 reps like that, you're gonna stand up and you're gonna reset the process. So you're gonna go back to dart, 10 more throws standing like this. From there, you're gonna go elbow up, elbow back, 10 throws using your arm. Get those. After those 10 throws, you're gonna go, same thing we did, face sideways, you're gonna get your elbow up, drive your hand in, finish your throw, 10 reps of that. And after you complete those reps, you're gonna turn the other way. This is called the football drill. And you're gonna rotate so your chest is open, elbow out, and you're gonna throw across your body. And this drill is really good for infielders to make those weird, awkward throws. So you're gonna do 10 reps of that. And then after those 10 reps, we're gonna step back and we're gonna use our feet. So we're gonna crow hop and do a complete throwing motion just like you would in a game. So 10 reps of the complete motion after you finish that warm up. Okay, so now that we're all warmed up, we got blood flowing through our arms, we're gonna move into some throwing drills. But before we move into those throwing drills, we're gonna learn how to properly hold the baseball. So, most elite baseball players will hold the ball like this, with 2 fingers across these seams. That's called a 4-seam grip. If your hand is too small right now, you're gonna use 3 fingers across those same seams, also in the 4-seam grip. So that will allow you to have proper spin on the ball when you're throwing it to your target, and so the ball won't move right, won't move left, won't raise or fall. It will have the proper spin and stay straight. All right, so let's get into it. Okay, so now we're gonna make some throws. If you're like me at home and you have no one to throw with, you can go out to a park or your garage or something and find yourself a flat wall and make throws off of that. So while you're throwing, make sure you remember everything we just went over. Make sure you have the proper grip. Make sure you're using your feet and working through the ball. A lot of mistakes I see are people, they pull their body away from the ball, they'll throw the ball sidearm. Make sure you're coming right over the top with the same grip and throwing it straight at your target. So it'll look like this. So you see how every throw I have the same grip, I'm using the same arm motion, I'm bringing my left arm through to create power, and I'm using my feet and moving towards my target. So those are the keys, is use your feet to move towards your target and stay consistent with your arm action on both arms. So like this. Just like that. So this week we went over the fundamentals of throwing. I know it's simple and it seems like you shouldn't have to learn it, but it is a very key aspect of the game. You're gonna stand up and you're gonna reset the process. So you're gonna go back to dart, 10 more. You can go out to a park or your garage or something and find yourself a flat wall and make throws off of that. So while you're throwing, make sure you remember everything we just went over. Make sure you have the proper grip. Make sure you're using your feet and working through the ball. A lot of mistakes I see are people, they pull their body away from the ball, they'll throw the ball sidearm. Make sure you're coming right over the top with the same grip and throwing it straight at your target. So it'll look like this. So you see how every throw I have the same grip, I'm using the same arm motion, I'm bringing my left arm through to create power, and I'm using my feet and moving towards my target. So those are the keys, is use your feet to move towards your target and stay consistent with your arm action on both arms. So like this. Just like that. So this week we went over the fundamentals of throwing. I know it's simple and it seems like you shouldn't have to learn it, but it is a very key aspect of the game. As soon as you get these down, the hard throws, the long throws, the underarm, the sidearm type throws become a lot more simple because you know the basics and the fundamentals. So let's go over those fundamentals. First, we started with stretching, so we had the Joes, if you guys remember that. So don't forget these before you start to throw. Second, we went over the grips on the ball. So remember, you want to have it in a 4-seam grip with 3 fingers if your hand is too small, with 2 fingers if your hand is just the right size. So those are very, very important basics. After that, we got into the 6 drills in progressions. So we started on our knee, and we're doing the dart drill, remember that? And then we went to full arm action, and then we went to use of both arms from our knee. After that, we stood up and repeated the same progression. Don't forget about how important these things are, because once it is ingrained in your brain, you won't forget how to throw. You just need to do these things. After that, we worked on actually throwing to yourself or a partner. So remember to use your feet, work through the ball, stay consistent, and the throw should come out nicely every time. In the next episode, we'll be going over the fundamentals of catching and from catching from behind the plate. So make sure you don't miss out on that.
Hello, welcome back to the stream. My name is Ronan Bryson. You've probably never seen me before. That's because I'm usually behind the camera, shooting these episodes, operating the live stream, doing some editing. But today, since Zach's away, I'm going to be reading out the Design, Make, Play questions. So let's go into it. First off, for the design episode, the question is, following the proportion guidelines Arian introduced, on which line do you draw the eyes when drawing a face? That one's a bit wordy, so I'll say it a couple more times. Following the proportion guidelines Arian introduced, on which line do you draw the eyes when drawing a face? So, following the proportion guidelines Arian introduced, on which line do you draw the eyes when drawing a face? You can look on our website to find this question as well, because I'd imagine you'd probably need to read it a couple times. Make, the question is, what's the ray that goes into the boundary called? What is the ray that goes into the boundary? What's the name of that ray? Play. The question for play is, how many fingers do you use to grab a baseball in a 4-seam grip? How many fingers do you use to grab a baseball in a 4-seam grip? All right, so those are the questions. You can send us the answers on Instagram or Facebook, or you can email them to us. You can find all the information on our website at zenmakerlab.com. Hope to see what you guys come up with. And now we're going to go into a segment on our face shields. So I hope you guys enjoy. See you next time.
Okay. Hello, my name's Siri Jones. I'm the Chief Bottle Washer at Zen Maker Lab. Really proud to be part of a cool team of engineers, artists, entrepreneurs, all walks of life. And we do some really fun stuff with education programs for STEM and STEAM, science, technology, engineering, art, mathematics, as well as a lot of cool service work, including getting into personal protection equipment, face shields. The story behind our involvement in face shields was quite interesting. We were approached by an association of community doctors, and what they needed was ability to test for COVID-19, and they just could not get personal protection equipment. It was just not available. It was sold out everywhere, and so they approached us. At the same time, we had one of our Maker Lab staff who was wanting to make some face shields for his parents, who were nurses at the local hospital. COVID-19, one of the first outbreaks in Canada, was just a few kilometers away from us in Lynn Valley. And so we wanted to do what we could to help. We were a team of engineers, we had fabricators, we had laser cutters, 3D printers, so we thought, why not help? Through our foundation, Access to Innovate, we decided we can help out, we can donate some face shields and make them. And in the process, we got some really valuable feedback from the doctors, the nurses, the frontliners about how we could improve the design, how we could make the face shield more effective. So designing the face shields was a really fun experience and really interesting because it involved a cross-disciplinary team, just like we teach our students. How do you go from an idea all the way to materialization and production? And so originally Zachary, our engineer, he worked on our first version of our face shield, and it was based on an open source face shield from Kousha Labs in the Czech Republic. Unfortunately, it wasn't quite suitable for the Canadian healthcare system. Health Canada had some regulations that we had to follow for the size and a few of the features. And so Zachary also was able to talk to the healthcare workers and get their feedback to how to modify and create a new design that suited Health Canada's needs.
So Zach, tell us some of the challenges that you faced during the production of the first version of the Zen Shield.
Sure. Actually, I've prepared some slides to demonstrate one of the challenges that we faced when producing these shields. So let's go ahead, let's take a look at those. So one of the focuses of this challenge that we had was conversion of units and figuring out what's the optimal number of things inside of things to better utilize the materials that we were using. So for the shields, the shields are actually made out of a PETE plastic, okay? So this is a thin film plastic, it's very clear. And this actually gets cut in the laser cutter. But before we can even fit it in the laser cutter, it has to be cut into these nice sheets. So we cut them into 20-inch by 30-inch rectangular clear sheets. And then they go into our laser cutter for laser cutting. So here you can see it's actually being laser cut in the laser cutter, and the sizing of the laser cutter only allows for these specific sheets. So this 20 by 30-inch sheeting size. For the shields themselves, at least for the kids versions, they're 18 centimeters by 22 centimeters. Like if you fit them inside of a box, that would be the approximate size, right? 18 centimeters by 22. So one question that we'd face for proper utilization of the materials that we have is how many of those shields can we actually fit inside of a sheet, right? So that's an example of one challenge that we would face. And so we have to figure out, okay, what's the best orientation? What's the amount of cutoff? Like how much is it actually utilized? Should we actually change the design to better utilize our method? Or should we change our method to better compensate the design? So these are some challenges that we face. And units are really important for when you're trying to figure this out, right? There's 2.54 centimeters in every inch. And that was really critical for figuring out how many of these face shields we can cut out of a single sheet. So not only did we face challenges regarding the utilization of our resources, we also faced challenges regarding production rates. As you know, 3D printing is not necessarily the fastest process. So to actually meet certain demands, we had to optimize the rates at which we were printing. So here's an example of one challenge that we faced there. So this is regarding rates. So when we first designed the Pro version of the face shield, we had 3D printed parts, okay? So here's our model of our 3D printed part, and we're gonna assume that the cross-sectional area, okay, so if I slice that anywhere, the amount of area, the amount of ink it would take to stamp that, say on a page, is gonna be the same, okay? So anywhere we cut it, we're gonna see the same. And you're gonna see that in the next slide when we look at the slicing software, okay? Right, so you can see each of those slices. We're gonna assume that they're roughly the same amount of filament. And additionally, you can see here that it looks like each shield has about 80 layers, okay? So each of these headbands has about 80 layers of material to make up the 3D object, all right, the 3D object. And finally, we take that sliced file that you just saw, and we put that on the 3D printers, and then we start to print them out. And each headband takes about 2 hours to print. So our question one of the questions that we faced was, if we reduce the resolution slightly, go from 80 layers a headband to 50 layers a headband, what is the printing time going to be for a stack of 5 of them? So rather than just printing one at a time, because that requires somebody to change them quite often, we wanted to print them in stacks of 5. So we had developed a model that was a stack of 5, but we want to know how long it would take to actually print out that stack of 5 if rather than 80 layers per headband, we had 50 layers per headband. So that's just one example of a challenge regarding the rate of production.
Ella then got involved. She's our materials engineer, and she did an awesome job of helping source materials that were environmentally friendly, that were recyclable or biodegradable. And she also helped with 3D modeling, creating the prototype, creating the files that we needed to laser cut and 3D print one of our face shields. And so she was fantastic in helping us get this face shield a reality.
For this Prusa face shield, we needed to revise it because we need to meet all the requirements of Health Canada. So we make the shield wider, and we also added this splash guard on top of it. For this design, which is face shield air design, we wanted to make it with just one material. So I needed to make all the hooks to connect the 3 parts together. So the hooks you can see here for the back strap, as well as here for the forehead strap. And I also designed the hooks for the top guard, and I really want to share it with you because it's very interesting. As you can see, the top guard is made of 3 rectangles, and I make them round on the corner to be more safe for the eyes and face. And you can see that there's this notch here on the hook to make that stay secure, and as you can see, it cannot move anymore. It's very secure here. That's pretty much what we considered for the design. Plus, we needed to consider the labor, the expenses, the materials, and also that we needed to make sure that it's comfortable on the face, as we might use it on our faces for more than 8 hours a day.
Once we had a product, then the next step was, how do we properly communicate this product to people that needed it, and the packaging considerations, the design considerations. So we had Greg, who was our design wizard. He had a really good sense of design, a good sense of color. And so he came up with some of the packaging for the face shields. All the information about the instructions, how to make the video to assemble it, things like the barcode and the stickers. So these are all things that you don't necessarily think of when you're launching a new product, but which are very important in order for it to actually be usable by retailers and things like that. So that was Greg, and he played a really important role.
Every day we came up with almost a different iteration of the product. I was observing the product development side with Ella, who's our materials engineer, and Zachary, our production engineer, with the laser cutting and the 3D printing. So I had my eyes on the process from the back end, and then with Siri, we sat down together to create the bridge between the back end, the creation of the shields, and the front end, which is the customer side. And my job, my role, was to make it look good, create a branding concept and a look and feel that would be compelling for a customer to want to buy our shields at the store level. We have 3 different types of shields. On the Frontliner shield, this is a fully assembled Health Canada licensed shield. So we have all of our core requirements with branding and marketing. We have our Made in Canada symbol, we have our recycling symbol, we have the product name, we have our Health Canada licensed manufacturer and MDL number as a company. We also have on the card bilingual description of the product. So we have, it's a personal face shield, and it's in French, it's masque de protection, and all these are requirements of some product collateral that we created. So the reason why we came up with a 4-fold that will insert to the poly bag with the frontliner assembled shield is we wanted to have this card with some cross-promotion marketing material from Zen Maker Lab. So we have a discount code that, once you buy a shield, if you're interested in learning about who we are at Zen Maker Lab, you are able to put in a code and receive a discount on an academy learning program for your kids. So there's maintenance regarding the cleaning of the shields ongoing. We've put that information in. And yeah, we've put our address in here and our domain name. So that's the marketing collateral that goes in with our top band shield, the frontliner.
Again, once we had the product, we had to do a lot of testing. And Carla, our communications manager here at Zen Maker Lab, did a lot of testing, wearing the face shield, seeing how they worked. This is one of our original versions of the face shield. How can we make it so that it's more anti-fog or anti-glare? How can we modify some of the components? And what is it like to wear one of these all day? Not just to try it for a few minutes, but to really see what it's like as an end user that has to wear it all day. And so we made some modifications based on her feedback. She also was involved in our Access to Innovate Foundation in terms of donating face shields to different organizations. And so she took care of that part.
Okay, at the beginning, I support the research part, then the testing. So we started bringing feedback about the face shield. We were wearing these ones every day. Then I started the promotion on social media. One of the biggest channels was Facebook. We started getting orders from different provinces. That was a big surprise for me, for example. I thought that most of the orders that we got were from BC, and no, big surprise. Most of them were from provinces like Saskatchewan, places like United States. They start ordering. Group of people, like doctors, for example, statisticists, they get really interesting on our product. At the beginning, the Pro, then when we launched the Junior, parents, they were asking for the product on Facebook. And of course, they just went to our shop and they bought the face shields. It was really nice experience. We got a lot of feedback and people mentioned some benefits about our products.
The special thing about Zen Shields is we were able to, through this diverse team, design a really functional product that protects people as much as it possibly can. And we feel like we're doing our part to help with COVID-19. At the same time, it protects the environment. We really did everything we possibly could to find materials that were recyclable, biodegradable, so that in essence we are protecting people, our communities, as well as protecting the environment.
When I was younger, my dad had a bunch of old computers in the basement, and we were fans of all kinds of shows, but there was one in particular that involved Digi Monsters. I don't know if I'm allowed to say the actual name, but we used to pretend that we could create little Digi Monsters out of these old computers and pull them apart. And so that was really fun. I always liked pulling electronics apart and trying to figure out how they worked. And I think that's probably my inspiration.
As an engineer, that's an interesting question. So I really want to help people with their problems with my engineering design skill, and that's my passion.
I had a real desire to sell products, to create products, to be a part of the design and the making of those products. And when you have an idea and you want to have that product become a viable product in the marketplace, you learn how to create an identity around those products. And then I taught myself to use the tools and really looked at what products that I gravitated towards in the marketplace, what styles they were using, and then I taught myself how to create those graphics so that we could create a good emotional pitch at the end of the day.
When you see and learn new tools, you see that as an opportunity to express yourself, and you can create different things. On social media, of course, every time that you interact with people, you have the chance to create or work in a photo, or even just have a short sentence that maybe can just touch people. So it's pretty cool, and for me it's brand new because this is in English, something that is new to me, right? So creativity every day, innovation every day, prototyping all the time. So it's really nice.
The other thing that was really cool about it is we had this diverse team from all walks of life, from all parts of the world working on this. And someone said for this package, for example, like who should go be the model in the package? And someone said, you should have someone that looks Canadian. And we thought, well, what does that mean to look Canadian? And we looked around at our own team of about a dozen people from all parts, corners of the earth, and a super diverse team. And so we've decided what we're doing with the packaging is we have the different pictures of the different team members, and we're profiling them because that's Canada. We come from everywhere, all over the world. We are Canadian, and we're really proud that this product is made in Canada. And that was an important part for us as well, seeing this multicultural, diverse team coming together, creating a really awesome product that we're all proud of.
Good morning, everyone. Welcome to Design, Make and Play show. Today, we have an amazing guest. His name is Fardeen Barakat. He is an engineer. He has been working with us for so long. He's an expert in electronics and everything. But let Fardeen to tell us a little bit about himself. Hi, Fardeen. How's it going? Good, good. Okay, Fardeen, just could you introduce yourself a little bit and tell us what exactly you do and you have done?
Yeah, I'm an electrical engineer from, originally from Iran, and then I've been in Canada for the past 16 years, and I've been working for the past 9 years as a electrical/mechanical engineer. And job-wise, I design product for consumer goods, industrial systems, some AI, and some instrumentation as well.
Oh.
So as for side projects, I do a lot of like side stuff, mostly actually at Zen Maker Lab. So yeah.
What kind of projects and classes have you taught here with us?
I have taught 3D modeling with Fusion 360. I've taught electronics class that kids can make, students can make like a very simple passive circuit with for a night light that automatically turns on at night and turns off in the morning. That has a sensor for ambient light. Some projects that are Arduino based, like for example, LED clock, or RC car, which is a remote control car that you can control with your mobile phone via Bluetooth.
Oh.
So, yeah.
Oh, just give me a second. I want to just change my naming here so people can see that I'm not Siri Jones. I'm Carla Vecino. Fardeen, I have another question. Kids, do they need to know things about electronics just to join those courses?
Some level of curiosity is very much appreciated in kids. Let's say when the students come in and we show them a resistor and we say, okay, this thing is a resistor, what's it used for? And then we say, okay, so this resistor resists the flow of electricity, and the kids get curious. So, and then they ask, okay, what's it used for? We say, okay, these things sometimes is used for protection in electronic circuitry, sometimes used for logic, and some other, like, let's say if you want to protect a component, or you want to restrict the flow of electricity to certain electronics components that are sensitive, then you use a resistor. And then, okay, what is a volt? And then what is a current? And then all these questions come back to back until you get to a point that the students understand the general concept of electronics and electrical circuitry. And then we teach them about, let's say, a night light, where they gather all of those information based on what they've learned about the key concepts like resistors, capacitors, inductors. There is current, there is volts, there is electrons, and basically they get to understand what it means. What they get to understand on a very basic level what they have in their pocket, as for example like a phone or a smartwatch, or let's say what they're like a camera or even a computer. So everything, and it's very needed for students to know this type of to know this knowledge, because
it's practicum, right? It's practicum.
Yeah,
it's something that you can see every day, right?
Yeah, they're going to be facing it every day of their life. Even though some might not actively, like some might not care what's going on in their phone, as long as they get to use it, that's fine. But for the curious students, then it's a great knowledge to have.
So basically, everyone can just come here, register, take the courses, electronics or robotics or coding, and they're going just to get the understanding, right?
Absolutely. Even some of the students that I had the pleasure of teaching, some of their parents were actually interested in the same concept, so they came in and they sat with the students and actually learned. So this goes to show that even parents can take advantage of this type of teaching material that we offer.
What about those students who like design? Are they just in the capacity of learning those kind of new concepts and put it in practice and become with a really cool project?
Design is a big term. What type of design are you specifically referring to?
Maybe functional design?
Like a product design, we have different designs. Like for example, they can do design with Fusion 360, which is a 3D modeling platform. They can do design for electronics, where they design a circuitry type of thing that, let's say, does something. For example, case in point, the night light, or they can do artistic design. Like let's say some type of graphic that on the computer with, like, let's say Microsoft Photoshop or Paint or something. Those are all different forms of design. The design that I'm talking about and I teach to students, and also other employees at Zen teach, is pretty much technology design. Like for example, technology design, and using the same technology and using the same design design concepts to manufacture or make a product. And at Zen, let's say we teach the students 3D modeling. The next step after that is, okay, once you do a 3D modeling session, then they get ideas and they can make their ideas come to reality using a 3D printer, or even a laser cutter. So those machinery are the next step after the design process.
Okay. I heard that. Sorry to interrupt. I heard that you are really a specialist in Fusion 360.
Yeah.
So again, it's good just to have some basic concepts about design just to join that class.
The design. So Fusion 360 is a very professional grade 3D modeling software, and industrially, like nowadays, like in an industrial sense, the market has been accustomed to SolidWorks, which is a industry currently it's an industry standard software for 3D modeling and 3D design. But the way I've seen it in different companies, it seems like there's a shift in the industry that's changing from SolidWorks to Fusion 360. And the reason for that is the ease of use, and a big reason for that is the cost of ownership of using the Fusion 360 software, which is currently actually is free for students, for hobbyists, and for people that just wants to learn.
Oh, I see.
And even though if you want to get a license, it's like a factor of 10 cheaper than SolidWorks, and this is the main reason that I see the industry is slowly shifting towards the Autodesk Fusion 360 platform.
I'm asking you all of this because I got a design. Let me see if I can play the video. It's a really interesting one. I want to see if I can just play it directly.
You're talking about the boat?
Yes, I'm talking about the boat. It's really interesting. I imagine that you were designing that on Fusion 360 and then putting things together, right? Just give me a couple seconds in here. Maybe I can just play it from my computer.
I can also show you something on my computer too.
Just give me a second. Open file. So it's really short. This is your boat, right?
Yes.
Looks pretty amazing. Yeah, I'm playing the video in here. I don't know if you can see it, but I think all people are just watching it right now. This now is in the lake. It's turning around. Really, really cool.
Linked?
Yes, it is in here playing.
Okay, awesome.
Okay, so Fardeen, could you tell us a little bit about the process of the design and creation of this boat?
The design process, I'm just about to pull it up on my Fusion 360 emblem, and I can share my screen with you to show you what I've done, if that's possible.
Yeah. If not, you can just tell us like a really quick. We have just 2 minutes.
I have it right here. Let's see. RC boat, and there we go. Okay, so sharing screen is.
I have it here.
Oh, share screen.
Okay, so I just.
Please, you're gonna enable my share screen.
It's here. Oh. No, it doesn't share. Okay.
No, not you, me.
Oh, sorry.
Me, I'm sharing my screen.
Okay.
So, cancel.
Stop sharing. So, technical issues, but we have just 1 minute, Fardeen. So, I think if you can just tell us a little bit.
So, well, it would be better if I could show you the design and then from the video you could see the thing. But overall, the design this is a slow moving remote control barge that the goal for this project was to design a platform for the water quality testing of lakes and rivers. Now, currently, Environments Canada is using very expensive and time-consuming process of testing the water quality for lakes and rivers, and I said to myself, okay, maybe there's a cheaper and easier way to do it. They don't have to get on a boat and go to the middle of the lake. They can put like some kind of platform on this barge that goes and samples water and brings a water sample back. it could be as easy as that. And then as far as power, I said, okay, if this is battery powered, it might run out of power, as it's going to do the test and coming back. So I put on a very heavy, actually, a solar cell on it, solar panel on it, which is 100 watts, and it's more than enough to actually. It has more enough power for the whole boat, so you can practically run it all day with no fear of losing power.
Incredible. Fardeen, sorry, I think I have to organize to set up another interview with you because we ran out of time. Thank you everyone for being here today in our show Design, Make and Play. Congratulations, Yaden, and see you tomorrow.